Next, we're going to learn about the formula for X-ray attenuation. So what is X-ray attenuation? Attenuation by itself means decrease in intensity. So when X-ray passes through our body, different parts, different tissues, it will be absorbed it will absorb, and different tissues will absorb different amounts. So what will come out, all right, we can calculate using this formula. So let's assume we have this layer of muscle with thickness of x. Okay, now the initial intensity before passing through this muscle is I naught, and after passing through muscle of thickness x, surely the remaining intensity will be less, and let's call it I. So why is the remaining intensity less? Because it's been absorbed by our muscle. So we say that this is called attenuation that causes your intensity to drop. So the formula is I equals to I naught e to power of negative mu x. So what is this formula telling us about so I is your final intensity. So you want to calculate the final intensity, you substitute your initial intensity, then you times the e to power of negative mu. Now mu is called the linear attenuation coefficient or linear absorption coefficient, which is sort of like a constant but not really a constant, because this value of mu depends on two things. It depends on the medium as well as the energy of your X-ray. Alright, so which means to say you cannot assign just one single value to muscle. You cannot say, oh, the mu of muscle is this, because if you change the energy of the X-ray, the value of the mu will also change. So what they will usually do is they will tell you, for this particular energy of X-ray, the value of mu of muscle is this, the value of mu for fat is this, the value of mu for bone is this. So if you fix the energy of the X-ray, then you can say that what is the value of mu for a certain medium. For example, this was given in one of your past years. They gave you some examples of the value of mu. So you can see for a particular energy of X-ray, the value of mu for bone is always the highest. That means it absorbs the most. Because from this equation, the bigger the value of mu, the smaller the value of the final intensity. So therefore, if you substitute the value for bone, then the final intensity will be very low, and the smallest value will be for fat. So you will substitute inside here, so the remaining intensity will be quite high. So this explains why when the X-rays pass through all these three tissues, and when they come out and when they hit the film, the area behind the fat will be the darkest, because most of it can penetrate the fat and will come out, so it will darken the film. But the area under the bone will be the least dark. That means it will be the lightest. It's because very little actually escapes after passing through bone, so it doesn't darken the film. You have to be careful, however, to recognize that this formula of I equals to I naught e negative mu x is specifically for a parallel beam of X-rays passing through the medium. Because if it comes out as a point source, okay, let's say you have a source here, and the X-rays spread out in all directions, it comes out as a point source, then the intensity will also decrease due to spreading, and the intensity will be inversely proportional to the distance squared. Alright, because it will form like a ball, and the total surface area of a sphere is 4 pi r squared. So we are not talking about this, however, right? So always remember that because it comes into the medium as a parallel beam, we don't have to worry about this, alright? So it will not have to obey this law. So then another factor we can discuss is what happens if you increase the energy of the X-ray photons. What will happen to the value of mu? Now think about it. If you use a higher energy X-ray photons, the X-rays will become more penetrating. And if it is more penetrating, less of it will be absorbed. So if it's less that is absorbed, the value of mu will decrease. So you increase the energy of the X-ray photon, the value of mu will decrease. Now there is also another term in X-ray attenuation called half-value thickness. So what is half-value thickness? Half-value thickness is the thickness of the medium needed to reduce the intensity of the X-ray to half of its initial value. For example, if you look at this graph here, Assuming that your initial intensity is 100%, the thickness of the material needed to reduce the intensity to 50% is called your half-value thickness. And this half-value thickness is consistent. That means from 50% to 25%, which is half of the initial, which is because this is your new initial, it will also take the same half-value thickness. Example, if there's 5 centimeters of muscle that will reduce your intensity from 100 to 50%, from 50 to 25%, also another 5 centimeters, from 25% to 12.5%, also another 5 centimeters. So this half-value thickness actually has some similarity with the concept we have learned before called half-life in nuclear decay. So therefore, the equation is also pretty similar. So I'm going to show you how to derive the equation for half-value thickness and its importance in our calculation. Now, let's say we start off with our original equation, I equals to I naught E negative mu x. Now, after one half-value thickness, all right, after exactly one half-value thickness, the final intensity will surely be half of the initial intensity. All right. So then we will call the thickness as x half. Alright, so we give it this symbol called x half. We cancel this I naught, then we ln both sides. So ln half is also equals to negative ln 2. And if you ln e, the ln e will disappear, so you get negative mu x half. So cancel the negative, and therefore the mu equals to ln 2 over x half. So what it means is you can actually find out the value of mu if you know the value of half-value thickness, which is sometimes useful because you may be asked to use this equation to calculate the final intensity, but they may not give you the mu directly, but they give you the half-value thickness. So you can use this formula to find the value of mu. So then only you substitute inside here, then you can find the final intensity.